All right, so the intermediate value theorem says if we have a function, okay, and that function can look like anything, and we have a value a here, a, and this is that's an a. Try that again, a, and this is f of a, and we have a value b here, and this is f of b. That all y values exist between f of a and f of b. Okay? If we have a continuous function, then all y values must exist between f of a and f of b. All right. Now, anywhere outside the bounds don't technically have to exist, but anything between those two must exist. That was the intermediate value theorem. That, by the way, unit 1. And then over in unit 2, we start talking about kind of introducing derivatives. Okay, where we had the average rate of change, which is basically your slope function. And then on to unit 5, we talked about the mean value theorem that says there is a value on the derivative such that the instantaneous rate of change is equal to the average rate of change. Now, the reason why we bring all this up is because these often do get confused with average value of a function. Okay, so the idea here is if I have this function here, and I want to know from -1 we have the value at 5, and at 3 we have the value at -3. Okay, and I want to know on that interval what was the average value for this function. Okay. Now, if I wanted to find the average of something, I would take, again, if you just think about numerically, if you want to find the mean or average value of something, you would take the total that it represents and divide it by how many you have. All right. So in this case, the total is our interval from a to b of f of x dx. Okay, that is our total. And then how many values we have would be represented by b minus a. So dividing your area by the change between your x values. So this is the average value of a function. You do have to be careful, okay? I think my AB calc had a couple of things about this. Remember we were talking about functions themselves that are rates of change? Okay, so you do have to be a little careful when finding average value of those functions. Okay, so make sure you read the question correctly. All right. So here we are. We have average value from -1 to 3. That would be 1 over 3 minus a -1 of the integral from -1 to 3 of 6 minus x squared dx, which is 1/4. Nope, don't need the integral anymore because take the antiderivative. 1/4 of 6x minus x cubed over 3 from -1 to 3. So that gives you 1/4 of, if I plug in 3, I get 3 times 6 is 18 minus 27 over 3, so minus 9, that gives you 9. Minus, I plug in -1, that gives you -6. And then minus, plus 1/3. So this ends up giving you 1/4 of 9 plus 5 2/3. Which is, going to run out of here, 1/4 of 14 2/3. 1/4 of 44 over 3, which is 11 over 3. I ran out of room there. All right. Now, next question you might get asked is, when does the function assume actually have this value? Okay, where on my function does this value occur? So the question is, when is 11 over 3 equal to 6 minus x squared? All right. So if I subtract 6 over, that's subtracting 18 out of 3 equals negative x squared. That gives you negative x squared is equal to negative 7 over 3, or x squared equals 7 over 3. And then we square root. Now, I'm not dealing with the negative value because the negative value is not within the interval. Okay, so I mean, you could have that because this gives you approximately 1.527. So again, it would be the same over here. 1.5, so right about here. Again, positive and negative, but again, I'm not worried about the negative because my interval stops right here. Okay, so at 1.527, we get 11 over 3. All right. Now, comparing average rate of change and average value function. So, for this function h of t, we get negative 16 t squared plus 41t plus 10. H is the height in feet, t is time in seconds. What is the average height? So they're asking for what is the average height? That is the average value of the function, because this function is designed to give you height at any point of time t. So if I want to know what the average height is, I want to know what the average value is. Now, over the first 3 seconds, that would be 1 over 3 minus 0, integral from 0 to 3. Now, here's a trick on the AP exam to save you time. If you have the function written in the question, you do not need to rewrite the function every time. So you can just write h of t dt. Because the function's already there, it's perfectly acceptable to just write function, because they know you don't have a ton of time. Okay? And we just put that in our calculator. So let me, my calculator, I got set that back up again. There we go. So now don't forget the 1/3. So second, 1 divided by 3. Math. Oh, one thing that might be interesting to know is that if you put your function here, let's clear this. So negative 16t squared, or just x squared, plus 41x plus 10. So let's quit. We can just go to variables, VAR, which is, I don't know if you can see the little circle move over here. Variables, and you can just go to XY. Is it variables? No. Where is it? Y variables. There you go. Go to Y variables. Hey. They took them all yesterday. Somebody, yeah. And you can just type in your function. Just press your first variable. And there's a reason why we want to do that. It's because on the next question, we're going to do this again. Okay. So we get 23.5. Now this is average height, and then height is measured in feet, so 23.5 feet. Okay. Now, the question asks, what is the average velocity during this? Now, average velocity is just slope. Okay, the average velocity is just slope. So that is h of 3 minus h of 0 over 3 minus 0, which is the reason why I wanted to point out that you can do that function variable notation, is because you can use it actually as function notation in your calculator. And what I mean is, instead of retyping the function and plugging each value and then find the values and then plug it all in, you can just say, well, go back to variables, your y variables, and then parentheses 3 minus variables, parentheses 0 over 3. And you get -7. So you can use that function notation in your calculator. Right? So again, these are things I'm finding out recently. So I'm letting you know as soon as I do. All right. All right. So now this is velocity, and velocity is in what? Feet per second. All right. So next question here, we have r of x equals 2 sine x minus 1, where r is the rate in which Mr. Brust's waistline is changing, inches per month, and x is time in months. What is the average rate of change in Mr. Brust's waistline changes from 10 to 12? Now again, this says average rate of change, right? So you would think this is slope. If you read the question, what is the function? It is a rate of change function. The function itself is a rate of change. So if you want to find the average rate of change function, and the function is the rate of change, what you're finding is the average of that function. Right? Now do make sure your calculator is in radians when you do this, because this is sine. But yeah, here we're going to do the integral, or 1 over 12 minus 10, integral from 10 to 12 of r of x dx. Okay, so again, this, it is 2 sine x minus 1, and this is 1/2, or 0.5, times the integral, because again this just gives you 1/2, times the integral from 10 to 12 of variable, y variable, enter. That gives you negative 2.683 inches per month. That is a great diet plan this guy's on, losing 2 inches per month over 2 months, so a total of almost 5 inches, or over 5 inches. That seems a little severe, though, so maybe not that great a healthy plan. I'm thinking Mr. Russ got some external help there. All right. Now, what is the average rate of change? Sorry, average change of this rate. So this is the average change in the rate of change. This is slope. So this is r. Now, first 5 months, r of 5 minus r of 0 over 5 minus 0. And that's what we'll plug in. So fraction variable of 5 minus variable of 0 all over 5. And we get he is losing about negative 0.384. Now again, because this is a rate of change of a rate of change, this is inches per month squared. So again, the difficulty isn't really doing the work. It's knowing how to set up the question. Because again, sometimes when you're asked to find the average rate of change, well, sometimes that's slope, and sometimes that's your average value function, depending on if your function is a rate of change function. It's important to note the difference. All right. Now, we've dealt with position, velocity, acceleration before. If you remember your position function, s of, we'll say t, if you take your derivative of your position function, what do you get to? Velocity. And if you take the second derivative of your position function, that's the derivative of velocity, which is acceleration. Now, the idea here is, well, what do we do if we want to do this backwards? Well, that means the integral of velocity, or the integral of acceleration, would give you velocity, and the integral of velocity would get you back to the position function. And again, it's more kind of obvious at that point, I think. So we kind of understand the concept that derivatives and integrations are inverse operations of each other. So we have a particle moving along the x-axis with an acceleration of 12t minus 4. The particle's velocity is 18 centimeters per second at time 2. The initial position of the particle is 8 centimeters. What is a function, x of t, that represents the position? So I want to go from acceleration to position, which means first I'm going to find velocity. So the integral of 12t minus 4 dt, well, that is what? 6t squared minus 4t plus some constant. And since I'm doing constant for velocity, I'm just going to put a little subscript here, v, for velocity. You don't really have to, but it does kind of help note that this is a different constant that I'm going to talk about in a moment. Now, because we know the velocity is 18 when t is 2, that means that 18 is equal to 16 times 4, no, not 16, 6 times 4, minus 4 times 2 plus whatever your constant is. Now that gives you 24 minus 8, which is 16. 18 minus 16 gives you 2 is equal to that constant. So velocity is equal to 6t squared minus 4t plus 2. Now, if I want position, s of t, well, that is the integral of 6t squared minus 4t plus 2 dt. So that's going to give you 3, no, not 3, because I have to divide by 3, 2t cubed minus 2t squared plus 2t plus your position. I'm just going to put x, the constant for x. All right. Now, the really nice thing is it says the initial position of the particle is 8. That right there, initial position is 8. That means 0, 8. So that means 8 is equal to 0 minus 0 plus c, whatever your constant is. So that means that this is just 8. So my position function, they wanted x of t, not s of t, which makes no difference for notation. 2t cubed minus 2t squared plus 2t plus 8. All right. Mr. Brust is driving across town to Mr. Sullivan's house to play with the new set of Star Wars figures. Mr. Brust's speed will obviously vary through the drive, but because he is so cool, he came up with a function that represents its velocity in miles per minute at any time t minutes since he left his house during the 30-minute drive. So, set up the expression of the following scenarios. Use a calculator to solve. It does say use a calculator to solve, so we are doing that. How far is Mr. Brust from his house after 10 minutes? So, if you want to know how far he is, that is just the integral from 0 to 10 of, again, I don't want to write the whole thing out, v of t dt. And we're just going to plug this into a calculator. I'm going to go ahead and put this as my function. So that is sine of 0.3x plus the natural log of x plus 1 minus 2. So I'm going to be doing the integral from 0 to 10 of my variable. So after 10 minutes, he has driven about 3.01 miles. We'll put the last zero in there you can, miles. All right. And the next question says, how far is he after 15 minutes? Well, that's just the same question, but from 0 to 15 of v of t dt. Now, what you can do to make this a bit faster is second entry to just re-enter in what you just typed in, change your top value to 15, and there you go. That takes about 3.397 miles. All right. Now, getting to the point of this question, really, Mr. Bruss arrives at Mr. Sullivan's house after 30 minutes. How far away does he live? Okay, well, assuming that the function describes the distance away, integral from 0 to 3, 0 to 30, of my v of t dt. All right. And I'm just going to plug that into the calculator. So second entry, change this to 30. About 22.824 miles. Now, what that tells us, what that tells us is the total change in position. Okay, based on this function, the change in position. Otherwise, what that tells us is the displacement. If we just take the integral, all we have is a displacement. Oh, here. Okay. Now, if you look at the graph, the way he was driving, he was going kind of the wrong direction for a bit. Okay, assuming he can't go straight to his house. And even right here, he kind of goes the wrong way for a bit. Okay. And everything above is hopefully going correctly towards Mr. Sullivan's house. Okay. So if I wanted to know how far he actually drove, how many miles he actually drove, what I could do, if I really wanted to, would be to find every one of these points, okay, where it crossed the x-axis, and I'm going to do the integral for this function, but I'm going to change the sign to make it positive. So I'm going to do negative integral for that function, plus the integral for that function, minus the integral of this function, plus the integral of that function. So that would tell me how many miles he actually would drive, no matter in the correct direction or not. But there is so much of an easier way to do this. Okay, the idea here is I need to make everything positive, right? Well, what makes everything positive? Yeah, you kind of get the note down the bottom. What do you see? Absolute value. So we're going to do the same thing, but we're going to do from 0 to 30 of the absolute value of v of t. Now, I can't do this on my calculator. When I say I can, but not the way I'm going to show you. On your calculator, there is two ways you can do this. The way I'm going to do this is I'm going to set up, again, it should be 30. So math integral from 0 to 30. 30. And on my calculator, I'm going to go to math and then over to number where I have the absolute value. And I think you could do that too. Go to math, over the number, you should see very top, ABS, and I can type in my variable here. Okay, and get it done. But also on your calculator, if you look right above the 0 button is the catalog. If you press second and 0, the very first thing that should pop up on your calculator is absolute value. So that is kind of the fastest way to do it. It doesn't work for mine because mine doesn't do A first. It does numbers and symbols first. So, yeah. Either way, you have a way to find absolute value. Do whichever you will. So we plug this in, and we get that he drove 28.503 miles. Okay. Now, what that tells us is that if you take the absolute value, the integral of the absolute value velocity, we get total distance. Do not confuse this. Do not confuse this with the absolute value velocity because that is just speed. Also, this if I take the absolute value of the integral of velocity, okay, whatever that is, that does not equal the integral of the absolute value of velocity. Okay, so you make sure you actually know where the absolute value goes. If I want to find total distance traveled, I do the integral of the absolute value, not the absolute value of the integral. Doing okay? All right, last page. Now, particle velocity is given by this function. Function represents the position of the particle along the x-axis. Find the position of the particle after 3 seconds if x of 0 is 5. Now, what this is telling us is this is our initial value. Okay, after 3 seconds, we want to know what is its position after it's already starting at 5, which means what do I have to do first? Well, I have to start at 5. Okay, so I'm already starting at the position of 5. My change in position, or my new position, is going to be whatever after that. Okay. Now, how do I find that? Well, that is the integral. That says after the first 3 seconds, starting at 0, from 0 to 3. Okay, 0 to 3 of my function. I don't want to write the whole thing again, so there we go. I'm just going to use my calculator. dt. Oh, wait, they do want you to do some of these by hand, so let's practice that by hand. Let me pipe that in there then. If we're going to do this by hand, we do have to write it in there. 4t cubed minus 6t squared plus 1 dt. That gives you 5 plus what? T to the fourth? Minus 2t cubed plus t from 0 to 3. A nice thing about plugging 0, since everything is a t in it, 0 is just 0. So really it's just 5 plus whatever I get when I plug in 3. So t to the fourth, 3 to the fourth is 81. Hey.
Cookies for your class.
Hey, you guys won. Good job, guys. Showing up yesterday and, taking your test.
You want to hand them out?
Yeah, just get that bit. All right, so thank you. Plus, so actually minus. So 3 cubed is 27 times 2 is minus 54, and then plus 3, that gives you 84 minus 54, so 30, and 30 plus 5 is 35. Okay. Now, with that in mind, how would I set up the second one? Because it's pretty much the same question, just you're starting someplace else. Okay, so how do we set up the second one? Where do we start at, by the way? If I have my particle's position after 2 seconds, given that x of 1 is negative 2, well, that means I'm going to start at negative 2. But instead of starting at 0, we're going to start at whatever value they gave us for x from 1 to 2. So 4 of t cubed plus 6t squared plus 1 dt. So let's see here. We already know that this is going to be negative 2 plus the, t to the fourth plus, no, plus, should be minus 2t cubed plus t from 1 to 2. So that gives me negative 2 plus, if I plug in 2, I get 8 minus, not 8, 16 minus 16 plus 2 minus, I plug in 1, I get 1 minus 2 plus 1. That is 0. This is 0 plus 2, so negative 2 plus 2, which is 0. Now, this question is going to be kind of an odd way of doing things because we could find this so much easier just by doing geometry. Okay. But I'm going to show you how you're expected to do this if you're not given such a simple question. Okay. So, what's the total distance traveled by a particle during the first 4 seconds if the particle's velocity function is given by this function right here? Okay. Now, again, like I said, if we want total distance traveled, there's kind of two ways we could do this. Okay. One, we could just do the integral from what? 0 to 4 of the absolute value of v of t dt. All right. Now, what that actually gives you, now let's say you're not allowed to use your calculator. Let's say your non-calculator question. So this is, again, if you're given your calc, that's all you had to do. Choose that. But for non-calculator, well, how do you do this without the absolute value? The idea here is we need to find where the function gives you 0, where the function crosses the x-axis. So firstly, we're going to take v of t and set equals 0. Negative 1.5 t plus 3 gives me negative 3 equals negative 1.5 t, which just gives you, if you divide by negative 1.5, 2 is equal to t. So what I'm going to do, and let's say I'm not given this graph, so I don't know that automatically that this first value is positive. All right, and then the second part is negative. Let's say I don't have this graph, so I don't know any of this. What I'm going to do is I'm going to take the integral from 0 to 2, where it crosses the x-axis, of the, well, I'll write this as a fraction to make this a bit easier, negative 3 over 2 t plus 3. And I'm going to add the integral from 2 over 4, okay, negative 3 over 2t plus 3 dt. And what I'm going to do is when I find their values, I'm going to take the absolute value of both, because I don't know which one is positive or negative until I actually do all the math, okay? So once I find the integral, I'm just going to make everything positive. All right. So take the integral from this. Nice thing is this is just going to be the same integral. So from, if I raise power 2 divided by 2, negative 3 fourths t squared plus 3t from 0 to 2 plus the same thing, negative 3 fourths t squared plus 3t from 2 to 4. Now, plugging in 0 just makes it 0, and I only have to plug in 2 once, really. So plug in 2, I get what? 4. That gives me negative 3. Plug in 2, I get 6. All right, so that just gives me 3. Now looking at the graph, we did kind of tell that this one was going to be the positive value, so that's just 3. Okay, so I don't have to worry about taking the absolute value of that. It's already positive. All right. So over here, plug in 4. That is going to give me negative 12 plus 12. All right, minus plugging in 2, which is negative 3 plus 6. So it ends up being 0 minus 3 or negative 3. All right, now this is where I want to take that absolute value. So we get 6 total. Now again, we could have just looked at this nice linear function. We could have just graphed this, found the area of the two triangles, and then add them together, and that would have been fine. But you're not always going to be given a linear function. So you're going to have to, again, if you have to do this by hand, we're kind of preparing you for the hardest possible scenario, which is you're not giving a graph, you don't know anything about this. What do you have to do in those cases? Well, if you don't have the choice to use a calculator, this is how you set it up. You will find where the graph crosses the x-axis, okay, and then just do separate your integrals out using that value, okay, and then take the absolute value of each integral. Any questions? All right.